So let's look at how to use this equation the correct way. On this circuit, same circuit as before, we've got a 12 volt battery, we've got 3 resistors in series, 1 ohm, 2 ohm, 3 ohm. We've got some value of current flowing around, which is going to be the same everywhere, the same here as here, and even if we measure it in between, there only is one flow. But we've got 3 voltages present here. The voltage across the 1 ohm, the voltage across the 2 ohm, the voltage across the 3 ohm. And the only thing we know right away is that these 3 are bound to add up to 12. So in order to work out what these 3 voltages are, the first thing we've got to do is work out the current that's flowing. The total current flowing is going to be, as always, V over R. But the R figure here is going to be the total of these 3 resistors. If we want to know the current flowing through the whole loop here, it's being restricted by all 3 resistors. So 1 plus 2 plus 3 is 6 ohms. So the voltage is 12, the resistance is 6. So the current flowing is going to be 12 over 6, which is 2 amps. So we now know that here we've got 2 amps flowing, and there's going to be 2 amps flowing there, 2 amps flowing in between, 2 amps flowing through each of the resistors. So if we take this top resistor, it's a 1 ohm resistor, and it's now got 2 amps flowing through it. If we rearrange this equation, instead of being I equals V over R, we can rearrange it to V equals I times R. Same thing, just rearranged around the other way. So if we want to know the voltage across this resistor, the voltage is going to be the current flowing through that resistor, which is 2 amps, multiplied by the resistance 1, which gives us 2 volts. So there's going to be 2 volts across there. And if we want to know the voltage across the 2 ohm resistor, this resistor here, it also has 2 amps flowing through it. So the voltage is going to be 2 times 2, which is 4 volts. And if we do the same thing for the last one, we get 6 volts. So putting our digital meter across this resistor, we would read 2, across this one 4, across this one 6, and if we add those together we get 12, because if we put our meter here we read 12 in the same way that if we put our meter here we read 12. And it's worth noting that if we put our meter here it would read 6, 2 plus 4, and if we put it here it would read 10, 4 plus 6. So just to recap, the first thing we did in solving this circuit was to work out the total resistance by adding the 1, the 2 and the 3 together to get a total of 6 ohms. Once we had the total resistance and we know the supply voltage, we could work out the total flow, which was 2 amps. And then knowing that that 2 amps flows through each of the resistors, 2 amps here, 2 amps here, 2 amps here, we're able to use V equals I times R, which is really just this equation swapped around, to work out the voltage across each one. You can have a go at a couple of examples similar to this.